Well, hey, I'm back. Part two for the Unit 4 review packet. Let me go ahead and pull up my calculator because I'll need a scientific calculator to help me do these problems. I'll see you guys later. And remember, if we're using sine, cosine, or tangent, we want to use a scientific calculator. Okay, so we are on number 17. We're solving for the missing variable below, round to the nearest tenth. So in this particular problem, our variable is actually theta in the problem. So don't freak out if you don't have an x or a y or something like that. It's very possible that you could have a theta in your problem here. Okay, so what that means is that if, so my theta angle is obviously theta. My side where the 7 is on, because it's across the triangle from the theta angle, that makes that my opposite side. The side where the 18 is on, because the 18 is all the way across the triangle from the 90-degree angle, that makes that my hypotenuse side. Okay, so when I look at the definitions of sine, cosine, and tangent, and I'm just going to write SOHCAHTOA right here, you can see that in this particular problem, this third side right here, which is the adjacent side, it's irrelevant to this problem. Okay, and the reason is because there's absolutely nothing there. So what you want to do is in your definitions, the adjacent side, so anywhere there's a in the definition, you eliminate that. So that tells me that cosine and tangent are eliminated as possibilities. So this is a sine problem. Okay, so you're going to have to use sine in order to solve this equation. The definition for sine is that the sine of the theta angle is equal to the ratio, the opposite side over the hypotenuse. We're going to use the diagram to fill in to create an equation. And my equation is going to be sine, and now theta is going to stay theta because I don't know what that is. That is equal to the opposite side, I substitute the 7. The hypotenuse, I substitute the 18. So my equation is sine theta is equal to the fraction 7 over 18. So I want to know, what does theta equal? So how I do that is that I have to eliminate sine from my equation. And the way that we eliminate sine from an equation is that we multiply it by its opposite or its inverse, which is the sine with the -1 for an exponent. We call that the inverse sine, and we have to multiply both sides of the equation with the inverse, that sine -1 function right there. Okay, so here's why we multiply sine with the opposite, or the sine -1. When you multiply the sine -1 with the sine, they cancel each other out. And when they cancel each other out, that leaves me with theta. So I get the equation theta is equal to sine -1 of the fraction 7/18. And at this point, you let your calculator do the work for you to see what is the inverse sine, or the sine -1 of the fraction 7/18. So I'm going to go to my calculator. Notice I just got sine -1 to show up. And then after that, I type in the fraction 7/18. And I don't know if you noticed, to type in the fraction, I used the division key. I typed in 7, I pressed the division key 18, and there's my answer right there, 22.88538048. And I'm going to round to the 10th, so this would round to 22.9. So theta is equal to 22.9. Okay, number 19. Solve for both variables in the diagram below. Both variables, I've got an x variable, I've got a y variable, and what you want to do in this problem is that you want to recognize that there are two similar triangles in this problem. We've got one triangle, which is the yellow one, which is inside and similar to the entire picture, which I'm outlining in blue. Okay, so this is what we talk about. You have overlapping similar triangles. And remember, one strategy that you want to use is that when you have triangles that overlap, just to make your life a little bit easier to see what is going on, is you want to redraw the two triangles separated from one another. So in the yellow triangle, we're going to fill in the three sides. The left side has a length of x, the right side has a length of 12, and the bottom has a length of 8. In the blue triangle, the bottom has a length of y. The right side has a length of 15, and then the left side of the blue triangle, as you can see over here, it's the combination of 1 and x together. So you would add those two up, and you would represent that as the expression x plus 1. Okay, now these two triangles are similar to one another. So remember, when triangles are similar, you're going to write ratios, you're going to write fractions, and after you write the fractions, you're going to cross multiply. Okay, now when I write my fractions, my ratios, I'm always going to put the yellow triangle's values on the numerator. So I'm going to pick a side from the yellow triangle. Let's start with 8. And then I'm going to make it the fraction or the ratio, the side that corresponds with 8, but in the blue triangle, which is y. So one of my ratios is 8 over y. Another one would be 12 corresponds with 15. So another ratio would be 12 over 15. And a third ratio would be x in the yellow triangle corresponds with x plus 1 side in the blue triangle. So my third ratio would be x over x plus 1. Okay, and then what I do is I'm going to cross multiply to solve for x, and then I'm going to have to reset another problem and cross multiply to solve for y. Now, when you cross multiply, you only need two ratios or two fractions. So I'm going to solve for x first. So I'm going to choose the fraction or the ratio x over x plus 1. And I'm also going to choose 12 over 15. You don't want to choose 8 over y with x over x plus 1 because that would create two different variables in the same problem. I cross multiply. And I can do that because these ratios are equal because the triangles are similar. Okay, so 15 multiplied with x, I'm going to multiply those two together. That is 15x. And I'm going to cross multiply the 12 with the x plus 1. So I'm going to multiply the 12 with the quantity x plus 1. I have to distribute that, so that gives me 12x plus 12. Now, whenever you cross multiply, the results are equal to each other, and I solve this equation. Subtracting 12x from both sides of the equation, that creates a new equation, which is now 12 is equal to 3x. And then I divide both sides of the equation by 3, so x is going to be equal to 4. Okay, so there's my value for x, is 4. All right, now I'm going to do the same concept to find y. So I'm going to choose the ratio, 8 over y, and then I'm going to go ahead and choose 12 over 15. Once again, you would not want to choose x over x plus 1 with 8 over y. You want to avoid, if possible, equations that have two different variables in them. And I cross multiply. So I multiply the 8 with the 15, that's 120. I multiply the y with the 12, that is 12y. Those two results are equal to each other. I divide both sides of the equation with 12, and I get y is equal to 10. So x is 4, y is 10, and number 19. Moving on to number 20, we're going to do 21. Okay, so the Clovis High's administration decides to see how many students eat the school's free lunch every day. The table at right shows a breakdown for the number of students for each grade. It was observed that 60% of the students eat free lunch. So the part A, complete the area model. So the area model here to complete it is we're just gonna be multiplying the two intersecting values together. Okay, so you would multiply 0.24 with 0.60, that's 0.144. That's what goes there in the area model. To get the area model over here at the top right, you would multiply 0.24 with 0.40, which is 0.096, okay? And you just keep multiplying, and these would be the values as you multiply the two values together. This is just a matter of multiplying. Just be careful when you're doing this. On a calculator, make sure you are putting the decimals in when you're multiplying, and make sure then when you get the answer, you read it correctly where the decimals are. Okay, and this is the results that you would get in when you fill out the area model. All right, now, part B, what is the probability that a student chosen at random would be a senior and eats lunch? So what we're looking for in this problem is we're going to our area model and we're finding the one combination. When you have the word and, it means there's only going to be one combination in your area model. We're finding the one combination of a person where the senior and also eats lunch. So you go to the senior, follow it over, and then the column for eating lunch is that first column right here. So there is the only combination in this entire area model of the 8 different combinations that happen that is senior and also eats lunch. So the answer is 0.156, or if you want to write it, you don't have to, 15.6%. Okay. Now we get to the second problem, C. What is the probability that a student chosen at random is a freshman? So we're going to be looking for freshman or does not eat lunch. Okay, so this one involves the word or instead of the word and. Now, when it involves the word or, what you're going to do is you're going to go to your area model and you are going to circle all of the combinations out of the 8 different combinations of freshmen, and then you also circle all the combinations that involve does not eat lunch. So first of all, let's circle all the combinations that involves a freshman. Well, we have a freshman who eats lunch, that's right there. And next to it, that represents freshmen who do not eat lunch. So those are all the combinations involving freshmen. Then we go to and we circle all the combinations of any grade that does not eat lunch. So we have freshmen who do not eat lunch, but if it's already circled, you don't circle it a second time. Okay, if you circle it a second time, that means you're counting the same thing twice. You don't want to do that. We have sophomores who don't eat lunch. That's the 0.088. We have juniors who don't eat lunch. That's the 0.122. We have seniors who don't eat lunch. Okay, so as you can see, not counting the freshmen and no lunch twice, there's 5 different combinations involving freshmen or any class or grade that does not eat lunch. So what you do is the word or when you do probability questions means you add. So you would add up all of these numbers together. So you would take 0.144, you would add it with 0.096, you would add it with 0.088. Just be careful when you're adding these and you get the decimals in the right spot. 0.112, and you're adding that with 0.104. Okay, adding all those numbers up, I'm just going to quickly do it off screen on my calculator. On the last one, you should get an answer of 0.544. 0.544, okay? Or 54.4%. So that would be the probability of a student chosen at random of being a freshman or A student that does not eat lunch. Okay, there's one more that I want to go over here. I want to go skip all the way back to the factoring problems, and I wanted to skip to number 8, where it said factor the expression completely. If not factorable, write not factorable. Now remember, as I said in the previous video, when you have a trinomial, when you factor a trinomial, you will use the area model and you will use the diamond problem in order to figure out if the problem is factorable, and if it is factorable, what are its factors. Now, before you fill in the terms, the 2x squared, the 2x, and the minus 12, in your area model and your diamond problem, you always want to make sure that there is not a common factor. In other words, you want to make sure there's not a number or a variable that can be divided into all three parts or terms of the expression. And in this case, you can see that you can divide everything by 2. Okay, that 2 is actually one of your factors. So it's actually called the common factor. So you want to divide out the common factor first. Now what that does is that then would create a new trinomial. 2x squared divided by 2 is x squared, plus 2x divided by 2 is 1x, or you could just write x, minus 12 divided by 2 is 6. Then you fill in the x squared, not the 2x squared, the 1x, not the 2x, and the minus 6 in your area model and your diamond problem. Negative 6 multiplied with x squared is negative 6x squared. So I put that at the top of my diamond problem. Okay, so just be careful before you factor. If there is a common factor, divide it out. Okay, now I solved my diamond problem. My diamond problem here would be a positive 6x and, oh, no, sorry, it would not be a positive 6x. It would have to be a positive 3x and a negative 2x on the sides of my diamond problem. Okay, I put those in, I fill those in my area model, and then I fill out the outside top and outside left of my diamond problem, and whatever goes on the outsides, top and left, those are my factors. So let's start with x squared. X times x is x squared, so I fill in x on the outside of each one. Let's follow the x from the top down. You would multiply 3 with it to get 3x, positive 3. So I have x plus 3. That means another of my factors other than 2 is x plus 3. I put that in parentheses. Okay, and then let's follow the x on the outside on the left over. You would multiply negative 2 with it to get negative 2x. So that means another factor is x minus 2. Okay, so, and then we just want to check. Notice in our area model we have a negative 6 in the bottom right, and we have a positive 3 and a negative 2, and those indeed multiply to make negative 6, so we're good. So my factors of number 8 would be 2 multiplied with quantity x plus 3 multiplied with quantity x minus 2. Part 2 of the Unit 4 review packet.